Hello again, everyone. Mr. Cruze here with another Trig lesson for you. This time, we're going to solve some quadratic equations by factoring. Alright? I know I'm not here today, but this video is meant to help you along with this process. I kind of already went over it a little bit on Friday, but just figured I'd go over it again with you. So please watch this video, and then after that you may work on your assignment. Alright? So the first thing is, when you're solving quadratic equations by factoring, which is one of the many ways you can solve quadratic equations, the first thing you want is you want to be equal to 0. Before you start off, you want everything on one side and nothing on the other side. So on this first one, we are perfectly okay. I believe I've already done this one, so that shouldn't be too terrible. Once you're equal to 0, you look at the first part only. We'll ignore the equals 0 for now. So we're only looking at 3x squared minus 2x minus 1. This is where we use that Hensley method. We're going to go ahead and break apart into two binomials. I suggested on Friday that you drop the squared like it's hot. Drop it like it's hot. So we're going to have 3x and 3x in both of our binomial terms here. Then what you have to do is you have to multiply the first term times the last term. So in this case, 3 times negative 1. Which is negative 3. So now I'm looking for two numbers that multiply to a negative 3, but they still have to add up to whatever this middle number is, in this case a negative 2. So I think about things that multiply to negative 3. There's not a whole lot that comes to mind. It has to be 3 and 1, right? Well, the only way they're going to multiply to a negative is if one of them is positive and one of them is negative. And the only way they're going to add to a negative is if the bigger number is negative. So it'll have to be a negative 3 and a positive 1. You can verify this if you want. I'm going to put the minus 3 in one of them and the plus 1 in the other. Since they both have the 3x, it doesn't matter which one goes where. Don't forget this is now equal to 0. We'll keep that in mind. But here's where it gets a little tricky. When you do the Hensley method, if I multiply it back together as it is right now, it does not give me what I started with, right? That 3x times 3x messes things up. So this is where you kind of have to pseudo-reduce. If there's anything you can divide both these terms by, which in this case there is, it's 3, go ahead and do so. So it becomes x minus 1. On the second one, there's really nothing that you can divide by, so it stays 3x plus 1. A careful multiplication back will show you that this actually gives you what we started with, okay? And you can always check that. I highly suggest you do, just to make sure you factored it correctly. That was the part we did on Friday, was just the factoring. Remember, you had to do the odds on the worksheet where all you had to do was factor. But today we're going to worry about solving, okay? What this is basically saying is that if you have two numbers multiplied together, they equal 0. Well, the only way that happens is if one of them, or both of them, is 0. So what you're going to do is you're going to set both of your factors equal to 0. And we're going to find out what x values that happens at. So solve both of these. Add 1 on this one. If you do, you get x equals 1. That's one answer. And on this one, you're going to subtract 1 and divide by 3. So you end up with x equals negative 1/3 for your other answer. Since this is an x squared problem, you should end up with two answers. The only time this won't happen is you could end up with two of the same answer, but that's still two answers, right? Just they happen to be the same. So be careful. If it's x to the third, you'll end up with 3, things like that. Okay? Not too bad. The hardest part is really factoring. Once you get it factored, it's just setting it equal to 0 and solving. So I'm going to try and breeze through these next few just to help you out. Again, I suggest you copy these in your notes and look back on these as good examples. First things first, I'm not equal to 0. I'm equal to a negative 6. So I'm going to have to add 6 to both sides. So I get 3x squared plus 9x plus 6 equals 0. Now that I'm equal to 0, I can start factoring like normal. The first thing you should always look for, I didn't look at the last one, I should have. The first thing you should always look for is there a greatest common factor? Is there any number that I can pull out of all of the terms? And it turns out in this case there is. There's a 3. So it becomes x squared plus 3x plus 2 equals 0. Now, once you've factored that, we're going to leave the 3 out front alone. That's not a huge deal. But we're going to go ahead and split the inside part. Again, drop the squared like it's hot, so it's x and x. This one's not too terrible, because anytime it's x squared, it's always a little easier. I need two numbers that multiply to 1 times 2, which in this case is 2, and add to 3. So what multiplies to 2 and adds to 3 in the middle? Well, that's 1 and 2, right? They're both positive. So plus 1 plus 2, and that equals 0. Is there anything I can reduce in either of those? Nope, I can't divide anything in either of those. So I'm good to go. There's my factorization. Now you're going to set each of these factors equal to 0. You might notice the first one looks a little weird. 3 equals 0. Well, when does that happen? Unfortunately for us, in this life, 3 will never equal 0. If it did, we'd all be rich, because we'd have $3 when we really had nothing. So this really isn't a solution at all. Okay? It'd be just the same if the 3 wasn't there. But the other two give us answers of x equals -1 and -2. Okay? Just be careful. If there's a constant out front, you don't have to worry about setting it equal to 0. But if there's an x out front, you do. So please, please, please be careful. Alright, C. Again, we want to get things on one side. We need to be equal to 0. But I see that this -12x squared out front is going to cause us some problems. We don't like negatives. We'd rather the x squared term be positive. So I'm actually going to move everything to the right. Again, this is more of a personal choice on my part. You really don't have to, but I promise the negatives get a little trickier if you don't. That should be a -6 on the end, right? Because you're going to add 12x squared and subtract 6 from both sides. Is there anything I can pull out of every term? Why, there sure is. I can pull out a 2. So I get 6x squared minus 7x minus 3. Right? Again, that 2 out front is not really going to cause us a problem. You should keep it in there because it's the correct factorization, but you really don't have to. So I'm going to drop the squared like it's hot on the inside part. I'm going to have a 6x and a 6x. And then you're going to multiply the first and the last terms together, which is -18. So I need two numbers that multiply to -18 and add up to the middle term of -7. Well, in this case, 9 and 2 immediately come to mind. And since it's a -7, the 9 has to be the negative, because it's the bigger number. So it'll be -9 and +2. You'll notice this time both of our terms can pseudo-reduce, right? 6x minus 9, I can divide both terms by 3. So it'll be 2x minus 3. I can divide both of these terms by 2, so it'll be 3x plus 1. Okay? And again, a quick verification will show you that multiplying that all back together will get you what you started with. So please be careful and be on the lookout for that. Okay? Now set every term equal to 0. The 2 equals 0 won't be a problem. So don't even worry about it. 2x minus 3 and 3x plus 1 equals 0. You should get positive 3/2 and -1/3. Those are your two answers. Okay? Example 3 here. Find the zeros, the x-intercepts of each function. It's all asking the same thing. Find out, where does the graph cross the x-axis? Well, the graph crosses the x-axis when y equals 0. Hey, that's nice. Basically, it's the same type of problem, isn't it? They're all asking the same thing. So first things first, GCF. Doesn't happen to be one. So I drop the squared like it's hot. And then I multiply the first and last terms. 1 times -14, it happens to just be -14. So what multiplies to -14, excuse me, and adds to -5? Well, that would be a -7 and a +2. So we have -7 and +2. So you set both of these equal to 0, because nothing reduces in our two terms. And we end up getting x equals 7 and x equals -2. That is where that graph would cross the x-axis. B's maybe slightly more complicated. Again, drop the squared like it's hot, because there's no GCF. Multiply the first and last terms together. So 3 times -4 is a -12. So what multiplies to -12 and adds up to the middle term of -1? Well, that would be a -4 and a +3. So it's -4 and +3. This time you'll notice you have to reduce, right? 3x minus 4 doesn't have anything that I can divide by, so that'll stay 3x minus 4. But 3x plus 3, I can divide both of those by 3. So that'll give me x plus 1. Again, I always check because I'm paranoid. Multiply those back together, make sure it comes back with what you started with. But anyway, set both of those terms equal to 0. And you'll get your two lovely solutions of x equals positive 4/3 and negative 1. Okay? Again, if at any point you need to rewind this, please do. But here's your assignment for today that I want you to work on. So you're going to finish worksheet 1.6. Okay? For today, you should have done the odds, where you factored only, right? All you had to do was just factor them. You didn't have to set them equal to 0. Today, you're going to do the evens. You're going to factor and solve. Okay? Obviously, the solving comes from factoring. So, you're going to finish the whole worksheet, and I will collect this tomorrow. As always, if you have any questions, feel free to email me, cruze@gws.k12.in.us. I will have my email ready, so I'll be able to answer your questions if you need. Or you can tweet me at Mr. Cruze Math, which might be a quicker way to get to me. Okay? I will see you guys all tomorrow. Please be good for the sub, and have a wonderful, fantastic day.